And welcome back, and it is the Further Maths 5 a day for the 23rd of March, and let's just get straight to it. Okay, so first question. So first question is a solve question. Now, before I get there, this is why I always say underline what you're trying to do. Always read at the end, because my guess is that some people will factorise here and forget to do the bit at the end. Anyway, let's go. Let's see how this happens. So I'm going to take away 4y from both sides, 4y squared, which is going to give me 2y squared. I'm going to add 3y to both sides. So I've used that, I've used my 3y, and I'm going to take away 13 from both sides, which is going to give me minus 9, and that's equal to 0. Now, again, if I was in an exam, I might be tempted just to use a quadratic formula because it's quicker, and I'm quite good at it now. But it's given what we're doing. Let's try and give it a go to factorise, because I suspect it will factorise given the nature of the question. So 2x and x. Now, that's a plus and that's a minus. So one of these is going to be a minus and one of these is going to be a plus, but I don't know which one. I also know that 9 breaks down to 1 and 9 and 3 and 3, but I'm guessing that it's going to be 3 and 3. So to be clear, that is what I'm doing. It is just clever guessing. It's not anything more than that. It's not that I have some clever way of doing it. I'm just guessing what I think is most likely. Then if I think about expanding it, well, 2 times minus 3 is minus 6 and minus 3 is minus 3. But I want this to be a plus 3 here, so therefore I'm going to do 2 times plus 3, which is 6, take away 3, which leaves 3 behind, and that's going to be my final answer to the factorising. But remember what I said right at the start, I'm not factorising, I'm solving. So therefore the answer to my question is, well, actually I've just realised, first of all, these aren't x's either, they're y's, so do be careful with that, because actually sometimes, a bit more A-level than GCSE, but they might take a mark off of that. But anyway, 2y minus 3, y plus 3, which means that y is equal to either minus 3 or 3 over 2. And that's it, question done. Nice question, that. Next question. How many odd numbers greater than 50,000 can be formed from the following digits? So what's interesting to note straight away is I'm using all the digits, so that's going to make it slightly easier. The next question is, because I want it to be an odd number, it must end in an odd number. So there's only one. I was going to say there might be 2 or 3, but there's only one odd number. So I know this last number is only one choice of number, which is the number 9. So I've used the number 9. I also know, because it's a number greater than 50,000, that the first digit can only either be 6 or 8. So I have 2 choices for the first digit. Now, if I've chosen 1, so I've used that up basically, I've used one of these up. So I'm going to say 6 is my proxy. That leaves 3 behind to choose, 2 left after that one, and 1 after that. Multiply all these together, fundamental theorem of counting. 2 times 3 is 6, times 2 is 12, and so my final answer is going to be 12. Not too bad, that one. That could have been much tougher than it was. Next question. Okay, we've got an algebraic fraction. Excellent. I like algebraic fractions. Now, as I have also said several times before, you would expect lots of things to cancel here. Doesn't always happen, but typically does. So you can often use the thing you factorise to help you know what you're looking for to factorise elsewhere. So if I do the example, I can show you what I mean. So if we start with the x squared plus 8x minus 20, I know that factorises down to x plus 10, x minus 2. So I'm expecting probably to see an x minus 2 somewhere. I know the denominator is difference of 2 squares, so that's going to be x minus 3 times x minus 3. And then I'm going to do this in one go. So I'm going to flip the second one. So x squared plus 3 3x factorises down to x times x plus 3. Already I can see something cancelling here. That's a plus 3, by the way. I think I wrote minus 3 twice. And x minus 2 is just x minus 2. I'm going to put brackets around it, even though I don't need to. Now I'm going to do this carefully so it doesn't get deleted and you can see what I'm left behind with. So my x minus 2's will cancel. My x plus 3's will cancel. And although that doesn't leave the easiest thing behind, it's definitely a lot easier than what I started with, which is going to be x times x plus 10 divided by x minus 3. And it'd also be acceptable to have x squared plus 10x on the top, but I think this is a slightly neater version. Either way, question done. Next question. Work out the values of x for which this is an increasing function. Now, it is not just a case that increasing functions means it's going up. It very specifically means that f dash of x, in other words, the first derivative, is greater than 0. So the first thing I'm going to do is I'm just going to work out what the first derivative is. A third x cubed, bring down the 3, cancels a third, and that just leaves x squared. 9 over 2 times x squared, bring down the 2 is 9, which gives me 9x. and I want this to be greater than 0. This is a quadratic inequality. So I know that this factorizes down to x plus 9 is greater than 0, which means my critical values are going to be minus 9 and 0. In other words, minus 9 from here and 0 from here. And I want all values that are greater than 0. And that's going to occur here and over here. So the answer to my question is I want x to be greater than 0, or I want x to be less than minus 9. So I'm a bit of a problem today, remember to put my minuses in. Minus 9. And that's it, final answer, question done. And indeed today done. Good mix of questions today. We've had quite a few days in a row, the questions have been quite mixed up. So if you haven't, this is the first video you've watched, definitely worth going back, going through some of these old questions because they sort of have switched around a bit for the last few days. Either way, do like, subscribe, leave me a comment below, let me know how you did, and I'll talk to you soon. Thanks all, bye.